Unit 8, Probability and Measurement, Lesson 4, Simulations. Your objectives for this lesson are to design simulations to estimate probabilities, as well as to summarize data from simulations. Okay, so a probability model, what we're looking at in this lesson, is a model that matches something that happens randomly. So instead of actually going out and doing whatever you're thinking of, you just model it. So for instance, instead of buying a lottery ticket and seeing if you win and going out and doing that until you win, you come up with a model for this. And this is a way that will help you recreate a situation to help you figure out the situation's probability. Again, this is useful if you were playing the lottery. That could get to be quite expensive if you just kept buying tickets until you won. Okay, so to design a simulation, you have 4 steps to design one. You want to figure out how many outcomes there are and the probability of each outcome, figure out what you're assuming, pick an appropriate model, and then define a trial for the situation and state the number of trials that you're going to conduct. So you're being very scientific about this process. Okay, so I have 5 types of probability models for you. So one would be a coin toss. This is a good model when you have 2 outcomes, so 2 possible outcomes. And they have an equal likelihood of happening. So both 50% likely. Okay. Another common probability model that you may have heard of is the dice roll. So, and usually in problems that you'll see on standardized tests, they're talking about a 6-sided die, but you could have more than one type of die. You could have a 4-sided die, you could have a 3-sided die, you could have a 12-sided die. Just usually what you're going to see, at least for my class, is a 6-sided die. So, and again, that would be good for if you had 6 possibilities, then you could assign one number to each one, and they're equal likelihood of happening. If you had 3 possibilities in a 6-sided die, then you could assign 1 and 2 to the first one, 3 and 4 to the second one, 5 and 6 to the last one. So that's another possible model. The spinner is a good one, and we're going to be using this in class. So the spinner is good because you basically have a circle and your pointer in the middle. And what's nice about this is that you can divide the circle up however you want to. So you could do like a 50-50 split like this. Okay. You could also have it split into thirds, or if you have a much greater likelihood of one outcome than the other, you could do an uneven split here, and that's really nice about this. So basically what you need to know about the spinner, if you're setting one up, there are 360 degrees in a circle. So if you have 2 outcomes, 50% likelihood each, you're going to multiply this by 0.5, you get 180 degrees. So this would be 180, and this would be 180 degrees. If you had, maybe this is like 12.5% likelihood, you multiply by 0.125. Okay, and you get your 45 degrees there. Okay, so you can multiply that 360 by anything. A card draw is another common one. In a standard deck, remember there are 52 cards, and you have 13 per suit. So 13 hearts, spades, diamonds, and clubs. and you have 4 of each type. So you have 4 kings, 4 queens, jacks, 2s, 3s, all 4 of those. Okay. The last one that you'll also see in class a little bit is the random number generator. So you can do that with your calculator. You can do that by pulling numbers out of a hat, but a random number generator. Okay. The law of large numbers tells you that as the number of trials of a random process increases, the average value will approach the expected value. So, for instance, I could model the likelihood, if I were to have a baby, I could model the likelihood of if I would have a boy or a girl by flipping a coin. And I might say that heads would be a boy and tails would be a girl. Okay? And maybe on my first flip, I get heads. Okay? So that would tell me, okay, if I had a baby, I would have a boy. And then the next flip, you would probably expect me to get tails because I just got a heads. So boy, girl, likelihood that I get either one is 50-50. But each flip of the coin is independent. It doesn't matter what the last one was. So maybe I get H again and again. But basically, the more times I flip that coin, the more it's going to even out. Okay? So maybe the first few, I'm kind of heavy on one of these variables. But if I flipped my coin like 100 times, not that I would have 100 children, but if I flipped the coin 100 times, I would expect to see about 50 heads and about 50 tails. So the more trials you do, the more times I'm flipping that coin, the more even and the more realistic the outcome is going to be. So it approaches what it really is supposed to be. Okay, so we have one example here. It is the only example on the video. It says Joni got on base 40% of her times at bat last season, and we want to design a simulation to determine the probability that she'll get on base in her next at bat this season. So for this one here, we have to first identify our possible outcomes. So the possible outcomes of her getting, when she gets to bat, is that she will either get on base or she will not get on base. And we already said that the probability of her getting on base last season was 40%. So this season, not this season, sorry. So the probability of her not getting on base would be 60%. So that was 100 minus 40 is 60. Now, notice that these are not an even split. We don't have 50-50. So something like flipping a coin or rolling a die wouldn't be the best model here. Okay. So what I'm going to do is make a little spinner. And it's not going to spin because it really is just a circle. But you'll see this. So I want to divide the spinner up into 40% and 60% of the circle. So I'm going to say 360 times 40% as a decimal is 0.4. And 360 times 60% is 0.6. And let's see what each of these is. So 360 times 0.4 gives me 144 degrees. and 60% is 216 degrees. Okay. So I'm going to kind of eyeball this here. In class, we'll actually use the protractors. 144 degrees is about here. So there. So this would be on base. And this would not be on base. Okay, so I want to know the probability that she's going to get on base her next at bat. So what I would do here is say, I'm going to spin this, I don't know, 10 times. And each time that I spin that represents one time that she is at bat. Okay, so if I spin it 10 times, that means that she'll have 10 at-bats this season. And that's kind of low. So we'll talk about that in a second. So she'd have like 10 at-bats this season. And I would record how many spins land with the arrow pointing like onto the on-base section and how many go into the not on-base section. And let's say we had 2 out of 10 on base after my 10 spins. Well, then I know that there is a 20% chance that she will get on base her first at bat this season. But like I just said, 10 spins is kind of low, and it's not really that hard to spin the spinner more times. So let's say she'll have like 100 at-bats this season. So 100, again, getting to a larger number, tells us that we're going to get to a more accurate result because of the law of large numbers. So that would probably be a better experiment. 100 spins for 100 at-bats. And you just do the number on base divide by total, and that is your percentage, your probability. Okay, and again, we'll be doing this more in class, so it'll be more concrete for you. But that is the end of lesson 4.